Hi there, welcome to the Network Freestyle. I'm Malcolm Daren,
And I'm Darren Fulwell.
and we are the Network Freestylers. Today we're on Freestyle 106, and we're talking about 5 design principles in network design. And the subject matter today is on scalability. Again, this is a freestyle based on one of Darren's blog posts, where you can find that.
Well, we'll put that in the show notes. But yeah,
You're not as
on
keen
my
to plug it
personal
this time. That was just the last time on the debut blog post of the series. But yeah, on Darren's blog, he's already written a blog around this, so this is to put some conversation about it. So without further ado, I'll hand over to yourself, Darren, and you can give an overview of what we're talking about today.
Okay, thanks, mate. The design principles, just as a reminder, that we were brought to light really as part of this blog post series with the ones that are listed on screen there is we talked through availability last time, where we were talking about how the network is there to ensure availability applications and services. The others you can see there are all beginning with S, which I wish I could have found something that began with S that meant availability, but would have been the
A
five.
couple of people have made an observation about that
Yes,
acronym,
yeah,
but we'll not. We don't need
yeah,
another
I know.
acronym, so we'll
My,
just say the actual subject matter.
my imagination didn't stretch to that, unfortunately. So obviously this time we're talking about scalability. That's the one that we'll cover in today's session. And really, I suppose, what does that mean? I mean, scalability is a pretty standard design principle. I think it's the sort of thing that everyone, when you're going through and first developing a feel for how you design networks, everyone talks about scalability, right? So let's just kill that off. Just bear with me. So what are we talking about when we're talking about scalability? From my perspective, there's kind of two areas to that, but let's just draw out a quick example, and we'll take it from there. Okay, so you've got similar to what we talked about before. We're going to have some users over here. If I can get my pen working. There we go. We've got a couple of guys over here who are busy using a bit of wireless network. They're connected through an AP into some switching infrastructure. That switching infrastructure might be connected to a core switch, let's say. I really do need to find better ways of drawing these things. You might have a router there with an interface connected to a circuit, which goes off into a network, a wide area network of some sort. That might come back into another router somewhere else, into another set of switching, which is another switch attached to it maybe, and then off into some server infrastructure where our application lives. So obviously these guys on the left are trying to talk to the application and use the application that sits on the right. But what happens when the network changes, right? No network stays the same. There's always a need to grow and change the network. And that can impact the environment all over the place, right? You might need to provide facility for more people. You might need new locations. You might need new applications on the environment. You may need different capabilities. So what we'll do is we'll just break those down a little bit, and look at how those play out in this sort of environment and the sorts of things you need to do to consider those elements. Okay.
Yeah, I think it's worth just mentioning. I think you mentioned it briefly at the start, but scalability isn't always about scaling up.
Yeah,
It can be about scaling down. So,
absolutely. I mean, when you're changing the network, you have that scenario, and let's face it, this is a CCDE scenario, right, where you have a divestment or that sort of situation where a customer might have a network, but then they might need to actually break it up and move and break parts of it away. The whole point here is you want to be able to grow the network or shrink it or change it in such a way that you're not impacting everybody else who's using it, right? That's the key.
Yeah.
In my eyes. But obviously, when we're talking scalability, we are typically talking about that increase in size normally.
Just a very quick description of a real life scenario where I worked on a network a few years ago that was part of like a huge bank. Like, so it was, the bank was like the overall, and they had like an investment company as a division effectively, and then within that investment company they had another, subsidiary divisions. The subsidiary division divested from like the investment company, but they were still the same organisation. So they came out of and they said, we're still the same company, but we're going to operate autonomously from an IT budget perspective, run our own infrastructure. However, we may need to merge back into them at a later date. And that actually happened. So there was like 2 years odd of like back and forth and building a greenfield environment to host their applications, divesting them. And then, after like maybe 3 years, they had to like merge back in. So when we were, designing the network, we had to plan it so that if they had to merge back in, then IPs didn't clash. And
and that's exactly the point, isn't it? That what you've got there is a scenario where if the network is designed for scale, it doesn't matter that you're going to reduce the sort of size of it and then increase the size of it again, because the scale is there inherent in the design, and that's the main thing. So
scale and modularity, but I guess you'll cover that later on, the modularity side of things.
Yeah, and I suppose the way I think of that really is both really those two things are kind of both part of the capacity argument, I suppose. So I'll just scribble that over here. So yeah, capacity where it needs to go up or it needs to go down. And let's draw some examples. So for example, we may decide that we need more people. Okay, so all of a sudden you've got a location where you're servicing them with a wireless network in order for them to access the application there. But all of a sudden, the company are doing really well, and so we need to hire more people. And excuse me a second. There we go. The joys of live whiteboarding, right? Yeah, so all of a sudden we've got a load more people arrive. Okay, well that's fine. How does that impact what we're trying to do here? Because if we've got all of these new people, all of a sudden we may not have Wi-Fi in the right place, or we might not have enough of it. So we might need to add. This isn't going. There we go. Yeah, excuse me. I'm just having some fun and games with new technology. I swap of laptop, but there we go. So yeah, new Wi-Fi. We might need a couple of those. We might need some extra switching to cope with that. Extra cabling. We might run out of capacity in the core of the network, so we might need to increase the size of that guy. We might need more bandwidth in our WAN. We may even need additional instances of the application down here on the server, and we might need to install a new server to make that happen. So obviously loads of elements there, and we talked about the availability piece around services last time round, and all of the different parts of the environment that are needed to make that application available. same principle here, that we have to look at the scalability of the environment from end to end. Yeah, and we have to worry about all of these things. So additional links might be required, to increase the bandwidth throughput, for example, into the server farm over there. All of those things, but these are kind of all what we call operating at a micro level. Really, these are things such as looking at the number of ports that are in use, or increasing the number of ports that we need, the throughput. Right, there we go. Let's try writing that again. The throughput that's available to us might need increasing. The capacity of the actual equipment itself, we have to consider. So things like capacity licenses on routers, for example, we might need to worry about those sorts of issues, and the size of circuits. So these are all individual bits of the links in the chain that might need to be increased along the way in order to cope with this new requirement. And can, so long as you're taking that into account when you're designing the environment, making sure that you're in a position to change any of those things, using modular switches so you can add more blades, ensuring you've got enough cabling in your environment to add additional links, buying circuits installed on a bigger bearer so that you're able to scale it up or down as necessary. All of those kinds of things come into play. So really, really key. But you might also have a requirement that kind of operates on more of what we call a macro level. So on a broader basis. For example, you might have a new location. Now, if you've got a new location, what we might still have this same issue with some of these areas where we need to increase, certainly at the application end of things, you might need to increase the scale of what's going on there. But at the access end of things, what you might end up with is a new site, okay, with lots of more new people. But these new people can't access the red or the black network there. They need their own network, so they'll have some blue network that goes in for these guys in their new location, and they'll need some switching that allows them to connect to a router that can then connect to the WAN so they can access those servers. Now, in this situation, what you want to be able to do is add new locations and new sites without impacting the old ones. So you're looking at a few things there. In my view, I think you've got a scenario where you need to have good, strong modularity in the network. So you mentioned that before there, Malcolm. Really key. If you've got a large location where you're adding a new building on a campus, for example, if you've got a modular design for your campus network, you're able to add new buildings and take buildings away fairly easily. It's a very typical scenario in a university, for example, where they populate and evacuate buildings fairly regularly.
Another kind of example I can think of is like hospital campuses. So,
yes.
And if you talk about like very high level, not going into too low level of the bits and bytes, but old school hospital. Let's not pick on hospitals, but let's say old school campus design, layer 2 stretched everywhere. Might be an access VLAN over a circuit that's on campus, and that needs to be changed to a trunk link to add additional, these additional services or whatever. And a way of providing modularity between those buildings would be to route between them, for example.
Exactly. Or at least ensure that when you put it in the first place, that you can put it in as a trunk even though
Yeah.
you're only going to want a single link initially, because there will come a point where you want to add additional services to that link. Whenever I use point-to-point links between anywhere, it's always as a trunk, regardless of whether it's, even if it's a routed link.
Yeah, because then you could have
at least gives you
multiple routed links with each in a VRF over the trunk, for
exactly.
example. Yeah. Or in
Exactly.
MLS.
So it just
Well,
gives you
not a trunk.
that bit more scalability in the environment, right? So it is thinking on in that bigger view. The modularity is useful, and another one is templating, obviously, because they will give you that that ability to reuse the same designs that you've used in one place to another. You've got the familiarity, so from an operational point of view, it's an easy thing to introduce into the network, but also from a day-to-day operations of switch fails. Well, I've already got a load of other switches here, all the same, because I've used the same switch model throughout. Those kinds of ideas, all really important, and all relating to this sort of scalability, because it's not just about the scalability of the actual network infrastructure, but also the scalability of the operations, right? You've got that scenario where you build a management platform for that network. That if you're going to scale the network itself up, you've also got to make sure that that management platform can scale the network, scale up to suit, and also all the processes that the poor management team have to go through in order to operate that network. So all of that needs to tie together.
Yeah.
Pretty key.
Yeah, I mean, it's an important thing that you just mentioned there about like the operational side, because if your network isn't scalable, and then from its definition in the project phase, as soon as you get a request to add something onto the network after it's in operations, operations will be expecting you to make them aware that you're making a change, but they would expect you, when you make the change, it's not going to knock out something that they're monitoring. Like, there's obviously exceptions to that, but we're just talking like in general terms. Like, so for example, if you've got a core, like, let's just talk old school networking, core distribution access. If you're adding an extra distribution switch to a production network, operations wouldn't expect the core to be knocked out.
No.
They would expect that a change was going to get made in a change window at a certain time, and they might be on a bit higher alert in case something happens. But they wouldn't expect adding a distribution block on with an access switch, etc., to cause an outage, for example.
That's the modularity piece, right? And the templating, I suppose, because it's expecting and knowing what to expect from the environment, because you've built it in such a way that making those kinds of changes doesn't have a wider impact. Yeah. So really, really key, that one. So that sort of covers the capacity side of things. I think there are obvious other things there, and lots of specifics, I suppose, you could look at. I mean, we've touched on a few there around WAN, for example, using large access circuits so that you're able to scale committed bandwidth up and down on them, using trunk links everywhere, so that at least you've got the opportunity to add further virtual or logical links over the physical link where possible. Always use
that could be for segmentation, so multi-VRFs, or it could be to deliver segmentation. So that could be segmentation from the perspective where it's like different customers or different customer profiles at the same site, or it could be one customer that needs to consume multiple services via a multi-service router at the site. So you might have a WAN link that comes in over one, effectively a VLAN, VRF or non-VRF, but over a VLAN, and then you may have SIP that comes over another virtual circuit, and you may even have an internet, like it depends on the environment, but it's multi-services or segmentation with multi-service usage. So
Exactly. So that was exactly where I was going next with this. Really, was that what you've described there is introducing new feature and capability into the network to cope with requirement. So this isn't so from a scalability point of view here, we're not just talking about capacity, but we're talking about capability. We're basically saying, right, okay, actually, I want to be able to perhaps put some security into the network, or I want to be able to give some separation between different parts of a customer. And so I need to virtualize elements of the physical network to make that happen. So
yeah, so
we'd
I
already
guess you
talked
could
about,
probably summarize it as scale. Scale the service capability. So
yeah,
it's scaling out the so not you're not scaling up the speeds and feeds. You're scaling up your the services and the ability to deliver different services to whoever your end customer
that's,
is.
yeah, that's
Like
exactly it.
turn on, turn off kind of model. Yeah.
Yeah, exactly. And like you say, from that sort of multi-tenant opportunity there, same kind of thing, right? What you're doing is you're throughout as you're building the network, you're selecting kit that allows you to do the virtualization. You're making sure that circuits will support that sort of segmentation and virtualization, um, and you're using configuration that allows you to use those techniques. And I think all of that is really, really important. There are other things that you need to think of there as well. There's the operating system of the devices themselves. Um, these can be modular, right? You can introduce new features into an operating system on the equipment just by installing software in some cases. So if that becomes a requirement, for example, I don't know, you're running a routing protocol in your LAN switches, and all of a sudden you want to be able to start running BGP, let's say, right? For a pure business reason, for example, you might want to merge two networks together. Okay, so you're scaling that network out. All of a sudden, you might want to make a sort of change there that needs new features in the network, such as running a different routing protocol. If you've got a modular operating system that you're using in that environment, you're able to introduce that feature either through licensing or through installing software on the boxes in order to support that. Okay. So that modularity. I mean, that if you hear much of the discussion about white box networking and disaggregation, that plays a big part in that decision, really, of whether you want to go down that path as to what sort of support you want for additional features and how you want to develop that. Because most of those platforms are Linux based, you're often in a position to install packages onto the boxes to introduce those new features. So that's kind of plays into it quite significantly. As in the future, and I don't think so much yet, but certainly will do, NFV, the network function virtualization, which is kind of it's kind of tacked on the side of software defined networking in most people's view. But I think in the original, if you go back to the original definitions, it was very much part of the idea was that you could have appliances, if you like, or devices that had these functions that you could bolt into them to do things like wireless LAN control and firewalling and those sorts of additional capabilities, but by pushing them out from a central point and managing them in that way, but pushing them out into devices. So, for example, if you start looking now at the Cisco routing platforms and at the Cat 9K switching, you're now able to start running new functionality on those by pushing packages out to them and installing software on them. Again, these things are Linux based now, so you've got that capability. NFV as a technology is as much about having the centralized control, if you like, from that central controller. So that's why it plays into the SDN sort of side of things. But it's much the same as and again, it's a new way of pushing those capabilities out.
And that isn't on even on the Cisco platforms. That's not confined just to Cisco technologies. So
no,
if you're a firewall, you're a checkpoint shop, for example, and you go down the NFV route. So just to enhance that a little bit at a high level. So what is NFV? It's basically network function virtualization. Is the term that's used as like the umbrella term for the whole thing. But then on a device, you have something called VNFs. So it's moving the acronym around. So network function virtualization is the the name for the overall I guess virtualization or putting virtual devices on. And the actual virtual devices are called VNFs, which are virtual network functions. So it's playing with words a little bit, but NFV would be an NFV solution would be right. I virtualize my routers and my firewalls at every site, for example.
Yeah.
What that would mean is you would have two VNFs. So you would have one VNF, which was, for example, a Cisco CSR 1000 router. And one firewall, a checkpoint virtual firewall.
Yeah.
And how you combine those together is you do something called service chaining, which is like you say, well, I want it to go to the router on VRFA on the LAN, and then hit the checkpoint firewall inside, go on the checkpoint. This is a virtual firewall.
Yeah.
The checkpoint firewall virtual outside, and I don't know whether you would need another CSR or you could bring it in on another VRF on that same CSR, but you get the idea. It's like that's service chaining, as you're chaining multiple virtual VNFs together to effectively deliver a solution on one box. And there's a separate discussion there around if that box fails, I've lost everything at the site. However, if you had like a physical firewall and a physical router, and the firewall fails, then you've still, unless you've got HA at every site, which is in hardware it's not really realistic. So especially if you're in. So that actually it brings like everything always comes back to availability that we discussed in the last session.
Absolutely.
Whether it's directly or indirectly. So
because you're right, because then it's down to right. Okay, if I need that application to be that available, then I put the appropriate HA or clustering or whatever in place to make sure that that's available. And then, of course, you need to ensure that from a cluster perspective or an HA perspective is scalable in the sense of being able to introduce a feature across the cluster. So it's basically it's just more grist to the mill, right? More things that you have to think about in order to deliver that scalable solution.
And that just in that very basic example that I gave, the centralized management, that could be achieved like for the CSR via Prime, just like any other device, and for the checkpoint firewall from the central checkpoint R70, whatever R80, whatever the version it is now, the central checkpoint manager. So that gives you, and when you start talking about like, well, I want to scale out my internet connectivity, it might be in a roundabout way. NFV is a way of doing that, because you would be able to you combine it with like an SD-WAN solution, you get a hybrid MPLS plus internet. You say, right, well, to start off, I'll just do the SD-WAN, but going forward, I want to go directly to the cloud from the site. So you can push your firewall policy out from a central management station, which then do an internet breakout. Yeah, it's like going directly to the cloud, but what you're actually doing is scaling your internet connectivity, because instead of going through a central pipe in the data center, you're scaling it out around your network.
It's a perfect example of the kind of macro capacity scalability we were talking about as well, because you're not just looking at taking a central point and expanding that out. I mean, in our drawing here, if this is our WAN, our private WAN, and I'm going to change my color again to, we'll go for orange this time. And if we've got, if we have internet off the side of this with a central point with a firewall on it, that gives us our internet connectivity. If we maintain that model, then obviously the pinch point there between the WAN and the internet runs hot, the more and more traffic you're going to put across this thing, which again is another reason why you might consider exactly what you've said, putting that internet capability out at each of the remote sites, because you've not got to increase your bandwidth back over your WAN from those remote sites, and you've not got to increase your centralized internet breakout.
So one other actual piece of the puzzle. So sorry, just while I remember, add an additional component, which in that, just because that's the example that we gave, but another component that you would likely have, if you imagine like you're breaking out from the site over the internet, you would go through an NFE, or like it could be a router with a UCS module and an application installed on that, or whatever the technology. It still effectively comes down to the same concept. Once you actually leave the site, that's firewalling in and out of the site, and there is some sort of scaling limitations. There'll be concurrent connections on the firewall. Depends if you put IPS on, what the security policy is. When you actually leave the site, you then say, or you leave the firewall, I should say, or maybe even before you get to the firewall, you have to think, well, how do I scale my content filter policy? Do I put like another VNF for a proxy at every site, which seems to me to be overkill? But you could, in theory, like maybe at key locations do that. But the other option would be you hit a cloud-based web filtering solution. So regardless of vendor, so you have your preferred firewall vendor that just does like layer 7 firewalling based on DNS or users or however your policy is constructed. But once you actually leave the site, it doesn't go directly to the internet or directly to the cloud. It would go via cloud web security or force point web security in the cloud, like the public cloud. So that was just another third component. But that can scale. That has basically no scaling limitations. That type of solution, as long as you size the site correctly after you leave the site. If you use like cloud platforms, once you leave it, you've got a global network basically there, from like Cisco or ForcePoint, WebSense, whatever you choose to use. So
absolutely. All that we've just said really around the ability to provide that virtualization, those virtualized functions and the VNFs, really key to the scalability of the network as a whole. So now it's back to similar conversation to what we were talking about with the availability of not looking at individual parts. We've talked about the micro level capacity stuff. We've talked about the macro level and looking at how the modularity and the templating and that sort of side of things works. We've looked at the new features and capabilities and how we use those. But then, of course, in order to make all of that work together, we then have to start thinking about automation, about how you can centrally control and manage all of the environment in order to ensure that the whole thing will scale up to provide that functionality. And I suppose the main thing with any operational system is to minimize the impact of change, right, to that environment. So to add new stuff, to take stuff away without making causing any impact on the wider environment. So you've mentioned already where we were talking about NFV and that sort of stuff, that centralized controller, things like orchestration platforms and that sort of thing become really, really key in this environment. In SD-WAN, that might be, from a Cisco point of view, that might be vManage, it might be DNA Center, and so on. You might be talking about Open Daylight in a sort of open platform, Contrail for Juniper, and so on. So the automation is just key to it all, really.
Yeah. I think one of the other things that comes along with the word scalability in this day and age is agility. It's agile, and agility is a buzzword, but what agility actually means in the context of network design now, a cloud service where you can go, regardless of the cloud vendor, where you can go and you can spin up. So there's another thing. There's two things. There's agility and elasticity. So having elastic networks, as it were. What that means is like you can almost like you have resources on tap. If you need a load balancer in a AWS environment, you go and you provision one, and there's no real like limit other than your wallet as to how many you want and how long you want them running for and all the rest of it. So elasticity and agility tie into scalability, and they're more like buzzwords. So you'll see in lots of marketing material like things have to be like agile, and agility is the thing that we need the network to be able to. And taking it a step further, what is agility? Why do you need it to be agile and things to be able to switch on? It's not because someone wants to deploy a new device. It's because the business say, we need to do business requirement X to stay competitive. And we have targets where we want to deliver this like sales campaign, marketing campaign. How are you going to meet that? And if you have to say, well, what we'll do is we'll go through like a design process for the next 3 months, and then we'll take 3 months to get kit ordered and provision a server, and and we'll get the application up, and then we'll get the server up, then we'll get the application on it, and that's all dependent on the network. Agility is it's there in some way, shape, or form, whether it's a design that just needs to be executed or whether it's a platform that needs something switched on. That's where the scalability, or I've got a server that needs more disk space. Okay, let's add another C series server to a Hyperflex environment. That's elasticity. Because you're scaling out. Just an example. The only other thing which is I've not actually seen it delivered. I don't know if you have from a telco yet, but the utopia is where you say, I need more bandwidth, then you go into a portal and you order it. I know some telcos do have that functionality, but it's like the account managers do it. So you say to the account manager, I've got 10 meg, I need to go up to 30 meg. Can you flex it? And then they'll go and do it in the background. But I've not come across a provider yet that the customer gets access to the portal. They basically log in with their account, which would be someone, and then they flex it up. And then that ability to flex up and flex down in busy and quiet periods is where the industry is heading towards. I think that
completely. It's all down to
do that,
it's all down to APIs, right? And having again choosing the right elements of your environment so that you've got that API access to do exactly those things. You mentioned the flexing up and flexing down of bandwidth with WAN providers. There are some providers who actually have an API that you just basically submit calls to, and it can pull information about what their current utilization is. It can pull information about what your current order looks like on a particular circuit, and you can submit increases of bandwidth requests through an API. Now, obviously, what that does is kicks off a workflow where it has to be authorized and so on. But that as a capability is there now, and you could, in theory, you could have pre-authorized arrangements, right, with people who could, so you can flex up and flex down within certain limits. So
yeah, it sounds great
absolutely.
until you get. It sounds great until you get to the billing part of it.
Yeah, of course.
Yeah, but
Um,
yeah, so
but
that's why it's
then
interesting to hear if you've heard of anybody that
no,
was
it is
doing that.
definitely a thing. Yeah, absolutely. And I think will only be more and more the case, because in theory, what we want to get to is a scenario where through a feedback loop, it comes back to the automation again, I suppose, to some extent. Through some sort of feedback loop, you're able to scale up and scale down automatically, right, within certain constraints. If you know that a particular part of the network, again, looking at the drawing there, you might have a particular pinch point in the coming into that data center, for example, and that data center might not be yours, it might be a colo or whatever, but you know that that's a pinch point. You may have some sort of arrangement whereby you can track the utilization of that link. When it starts running at sort of 80%, then go buy some more bandwidth automatically, if so long as you've got the appropriate commercial arrangement wrapped around that. There's no reason why that sort of thing can't be done. And I think that's kind of really when I look at this whole discussion about scalability, it's not about, as it used to be, speeds and feeds. It's not just about that anymore. You've got to look at the end to end. You've already talked a lot about the business outcomes, and that's the key part of all of these design principles that we're talking through. Is that what we're trying to look at here is what the business requirement is, and how we can use the technology to meet that requirement. That's our job as network architects. That's our job. Is almost to abstract away all the stuff that's going on under the hood that the network engineers and ourselves need to know inside and out, so that we can make sure that things are configured properly and so on and so forth. But keep all that in a black box so that the business people, as far as they're concerned, they get the capability they're looking for, and the performance of the systems, without having to worry about what's going on in those boxes, because we've built a scalable and available environment. So,
And to an extent, obviously they do care to some extent, but to more of an extent, or the business don't really care how it's done. They say, can you do it, and how much is it going to cost, and
exactly.
when can you deliver it?
And what we have to understand is how we can make it scalable, how we can make it available, within the constraints that we're operating, right?
And one of the things actually, but that will not go into the detail, but just as an example as well, because you one of the things, slightly off topic, it's more on a network architect, the types of things that you need to manage as a network architect. It might be that business requirement comes in, and you say, well, and then you say, why did I mention that in the first place? But you say, yeah, well, we can't deliver that in the timescales, but what we can do is this, or you might not. It might be something along that type of conversation, and the business will, more often than not, they'll say, well, will it make it work now? And if you say yes, they'll probably say, do it, unless you've got a pretty good argument against it. But that's where you have to be strong as a network architect, and push back in the right way, of course, and say, look, you could potentially put this in, but it's only a tactical measure, and then you're going to get disruption later on when we actually have to move the service. And then if they accept that, and they accept the risks that are associated with that, and the potential outages, then yeah, go with a tactical. But that's with the strategic and methodical thinking and all this stuff about not thinking in the micro all the time.
Yeah.
I would say as a network architect, you really have to think in the macro for everything. But in order to achieve the macro, you have lots of micros that make
exactly.
That.
Yeah. That's exactly what I was sort of getting at, I suppose. Yeah. Is like you say, from an architect's perspective, you've got to look at both, right? You've got to look at both, understand both, and be in a position where, you know, almost to kind of preempt any discussions, I suppose, that might occur later about making scaling an environment up or introducing new capability and new features. The more that you can prepare for that, and the more that you can build into your design so that you're ready for that essentially is scalability.
But also another caveat is one of the things that, you know, I'm sure we both learned throughout the CCDE was, you know, well, people say, well, what will I do then? Is I'll put the biggest box in with the most features within the price range, and that isn't always, well, that's not typically how you should approach it. You should approach it with that mindset where, you know, you can accommodate for future scalability, etc., but you don't do something that we call, I think this is even in the CCDA curriculum, is gold plating.
Gold plating.
Plating is putting every, you know, like basically designing on maybes, right, that are in your head. But if the business gives you a clear strategy to say, we will start off with 100 units of something, and we need to scale to 500 within 5 years. That's what you plan for based on the business, and perhaps a little bit of additional. And then, you know, you make, that's where, like, your job liaising with the business as a network architect to say, that's fine and that's what we've planned for. However, if you go to 1,000 units, then, you know, there will be the design won't change, but you may need to switch components and have capital investment in, like, upgrading equipment, basically. Because upgrading equipment isn't the same as like doing a redesign to accommodate, you know, a bigger version of what you've already got.
That's the important thing, isn't it? Is that you've designed to accommodate the existing requirement with a little bit of growth. So growth is one thing, right? Scale is that and then some. Yeah. So you've accommodated what expected or potential growth there might be within the confines of the project you're implementing, but by designing the environment to be able to be scaled, whether that's by adding more kit or replacing kit with more capable, higher throughput, whatever, you're basically achieving scalability. Awesome.
Sounds good. I think that might be a good note to wrap it up on then.
Yeah. No. Well, thanks for listening to me blather on again, mate. It's always good to do these. I guess anyone who's listening, thank you again for listening and watching. Always look forward to getting feedback. Any comments, corrections, criticisms, you know where to contact us. It's at Net Freestyle on Twitter. It's email is networkfreestylers@gmail.com, or you can leave comments on the YouTube channel down there, or again on the blog at networkfreestyle.tech. So really look forward to hearing what you got to say.
That's great. Thanks everyone.
No,
Cheers.
thanks. Now, see you soon.